Okay, here's part two of the player control script. Quickly, it's mine. I like to sell it, so please don't give away the source code. You can distribute the code, or if you use the code in your app, you can distribute the app all you want. There's no runtime license fee, but just don't give away my source code. I'm retired, and this is my extra lunch money. So there's a tool for documenting called Doxygen, Doxygen, and that's this particular these little @ signs. I use that over the Windows one because this works with Linux, it works with Apple, and it works with Windows. So it's kind of a nice. And so I've documented the heck out of this code, I think. Delegates, basically overall animation, overall jump animal comments, and so on. Description of the class. Movement type, we did it earlier. It's either apply force or use transform position. Uh, basic inventory system. I have it, its name, and what it is. Uh, and that's an array of property owned, which could be changed to a list if you need, or I might. Movement type again, and then I have some variables in here for. I made them public because I wanted to see them from the animation script, but I don't. As time went on, I stopped using them, but I may keep them public. I don't know. The basic directions, this is a moving direction. It's forward, right. These are all assuming that the player is facing forward. So, and this is the movement. So they're facing forward and they're circling. They're facing forward and they're going forward. They're facing forward and they're going backward to the left and so on. Compass directions are just that, relative to the world, not to the player. They might be used relative to the player in a place or two so that I can figure out the angle between two different degrees or two different vectors. So facing has a compass direction, a facing direction, which is the transform.position, transform.rotation. And facing angle is relative to north, right? I use that with some of the animation stuff to detect what's going on. Moving, similar, right? It has a general moving direction, right, relative to the player's forward. The actual moving rotation, moving angle, which is again in degrees, where this is a vector. Then the velocity of the player, which comes from their rigid body. So player control obviously needs a rigid body. I think it'll crash if you don't have one. This is the variables for players, the facing. So turning value, pan up and down. These are all those things we discussed, the serialized fields. Begin devices. This is where I defined what those are, and like I said, this will probably change over time and keep evolving. Delegates, this is the part you care about. It doesn't, this script or the input device doesn't say what keyboard or control actions cause an attack. I'll discuss that later. But if it gets to the point where this is just simply the movement script provides a common delegate interface. So in this case, it'll anybody who does the registers for this event with a plus equals their function name, it will tell them what direction they're facing and what direction the player is moving, right? So if I'm facing forward but moving to the left, that'll might tell me which animation to use. So you basically on attack plus equals your function. Same with blocking, buffing. I don't like that name. Buffing is kind of like, I dare you kind of a look. Take damage, die, eating, fainting, falling. That's the part of the jump where the guy's arms and legs are flailing a little bit. They're falling, so you can get one of those. Getting up, hacking. I got this actually from mining. It was a mining, and the guy without the pick in his hand was doing the pickaxe thing. But I actually ended up using it to make it look like, put an axe in his hand like he was attacking with an axe. So I called it hacking. You can put a pick in there and use it for mining. You can put an axe in there and use it for attacking. When they go to the idle state, this is called Melee, one-handed, it's kind of like a machete. Two-handed machete. When they're in the resting state, this one is invoked. When they're doing a roll, this one is invoked. And again, the animation helper script interacts with these and uses many of these. Idle and looking versus idle, and then versus idle and ready to attack, a little more aggressively looking around, is jumping. Left 90. You'll be notified when they, as I scramble through my notes here to see the exact numbers, you'll be notified when the player moves near 90 degrees. So if they're moving if they're rotating to the left between 24.75 and 247.5 and 292.5, it'll say they made a left 90. Similarly, if it's between 67.5 and 112.5, it'll say they made a right 90, even though, and then it tells you the actual direction that they were facing, that they are facing, and the direction they're moving. And I do this because for the animation, there isn't one that says I'm turning it 290 degrees. So it picks, a left movement as opposed to just making up a guess, right? So this is kind of like it went hard left, it went hard right, even though it's not exactly hard right or hard right left. On turn is similarly, but it only increments in 11.25 degrees. So if it's kind of a dead zone for turning. So if you're facing north and you just bump him a little bit, it's not going to send out this. They have to move at least 11.25 from the last time a turn was recorded. U-turn, same thing. If they're going forward and jam it backwards, this will do it. And that's between 157.5 and 202.5 degrees in change direction. Again, with run, however it is you want to activate run, when you do it, it will call on run and tell anybody who's registered for that delegate. Shooting is for a gun-like thing, and shooting arrow is for an arrow-like act. They're sleeping, casting a spell, strafing left or right, and you'll get the on strafe. The player is facing, and it'll tell you, and the player is moving. Between the two, you'll know what they're doing. Tired, a victory dance of some kind, circle walk. There was one little demo game I did where there's an animation where just circles. And so this is used if they go into just pacing in circles. Then same with walk. Panning is for the camera, although I've changed it from the camera to anything. With the camera pans, you might have more than one panning device. You may also pan like a statue that watches it or something, right? So it works for anything you're panning now. Whenever the player hasn't moved for that no idle time, this will be called in increments of the no idle time. And this is the collision stuff that ties in with it. I collided with something, which direction they were facing, which direction they were moving at the time, and what they collided with, which is the standard on collide stuff. Same with collision stopped, collision still colliding. Same with the trigger, right? They're the same stuff plus the player movement stuff, which you're always going to go get anyway if you need to know. If you bump into something, you might want to have it attack it or something, and so you need to know where it came from. The grab left and grab right, I use this as the shoulders on the Xbox and the grab button, which is the middle finger, I think, on the Oculus controllers. Same with select, triggers on the Xbox, and trigger left and trigger right. And like on the keyboard, I forget the buttons I used. It could have been left alt, right alt. I don't remember what it was. We'll get into that in another video here. Talk to computer. I have some text-to-speech and some speech-to-text games, or more application stuff. And so if they press the push to talk button, which in my case is you press down on the left joystick, it calls this, which activates the speech-to-text code, and that's what I use this for. And menu pressed is when they press the menu button. Take image, same thing. I have a button sequence you press, and it will take an image of, it takes a 360 degree image. I'll add that to here, but I believe it takes a 360. It might take a what you see image. I'll look closer at that. Anyway, you can look at the actual code when we get down there. Push to talk is different than talk to computer. Talk to computer was for speech to text, push to talk. Normally, in a lot of games, there's an open mic. You can do push to talk in one, but the reason I actually invented this is in a text to speech world, in a speech to text world, you press down on the left button to talk to the computer, like say something like open menu or um, send a message or something, because I can send text messages via verbal, right? I can press a button and say, tell Joe he's behind you and let go, right? Rather than saying it if we're maybe in some circumstances you might want to send a message. That was a bad example, but you know what I mean. But if I press down on the right button when we're in uh, team mode. So in team mode, the maybe the mic's live, but if I press down on push to talk, it only talks to my teammates. That might be a way that I use this. So that's how I differentiate them. You can use them for anything you want, but that's how I use them. Player present is when the headset is taken off or put on. Haven't found any way to tell whether the keyboard is used. I mean, I could do something like the user does no input for a certain amount of time and add that to the inspector. I might do that. But for now, this is basically saying the user has taken off their XR headset or they put it on. It's present. Player is not in the air. This used to be in the air, but that was a lot of, it just made the code kind of negative backwards for me. So when they jump, it's only sent once. When they go jump, you get their in the air. When they land, you get the other one. This is true when they land, it's false when they take off. You don't get a message while they're still in the air. And various private variables. And as you can see, I even use my own stuff inside of it. Now, I've got 45 years of writing computer programs on Linux, so it's the style of programming that I'm used to. I'll probably add a lot more comments by the time this is actually released. Here you go, invoke on player turn, and you can see this is from the input system. It calls me when the left or right arrow or the right joystick on the Xbox or the right joystick, I think it is, on the Oculus controller is invoked. I get the value, determine if it's in the dead zone, if the keyboard is enabled and they used it, if the path is whatever, if you can use an up-down pan, I do that, and so on. And this also worked with WebGL, except the new input system doesn't quite work right. So when I'm using the new input system, I have to set input method to both and activate this, because these just don't seem to work in WebGL mode. And enable moving, and see if there's anything interesting down here, and so on, right? But the source code is included, and we're near the bottom. Oh yeah, when the player dies, it disables a lot of the functions, right? They can no longer shoot, they can no longer whatever. You can enable and disable that with disable player acts and enable player acts. And if it's disabled, they can't do whatever it is you don't want them to do, right? It also stops them from moving. It stops them from, might let them turn. I'm not sure what I did, but you can always change that, and so on, right? So that's a way of kind of a globally of enabling and disabling it, and tweak the code if you want. Have fun with it. So that's the end of this video.